Hi, welcome to Real Learning Center where we focus on real learning. So we are continuing our journey on solar system. We have completed part 1, this is part 2 where we are going to discuss mainly eclipses. Okay, so most of us actually know how actually eclipses happen. But when you go through this, you will realize that there are many more things that we probably did not know. Okay, so we completed the part 1, which is Sun, Earth and Moon, okay, where we talked about who was at the center and who is at the center today and what causes seasons and is Moon at all rotating about its axis. These are the things we looked at in part 1, and if you have not seen it, please go and watch Solar System part 1. Okay. So part 2, we are going to start with eclipses. So now here is a mythological story which I was told when I was a child. Okay, I was told that the eclipses are caused because of the two monsters called Rahu and Ketu. Okay, so I was actually told that these two are Rakshasas or monsters with only their head being there. They don't have their body, and they are there in the space somewhere. Okay, and whenever they eat up or they swallow sun, one of them swallows sun, the solar eclipse will happen. When the Ketu swallows moon, the lunar eclipse will happen. So this was the kind of nice, interesting story that I was told in the childhood. But later, when I started studying the class, our teachers told us that no, that is not the case. Whenever sun and moon and earth are aligned in a line, these eclipses do happen. Okay, so today I am going to basically go and analyze that and see whether the story of Rahu and Ketu, was that true, or was it the teachers who told us that when they align in line, the eclipses happen? Is that true? Okay, let's see today. Okay, so Rahu and Ketu cause solar and lunar eclipse. That was a statement made to me when I was a child. So let's examine that. Okay. So let's start and understand as from our scientific understanding what is solar eclipse, okay, and what is lunar eclipse, sun eclipse and moon eclipse. Okay. So what I'm showing here on the screen is actually the sun there and earth in the middle, and earth going around the sun in an elliptical path, and moon going around the earth in an elliptical path, that we know. Okay, though I have written very long ellipses, but in reality it is almost circle-ish kind of ellipses, slightly elliptical. Okay. So let's see how moon goes around the earth. So moon goes around the earth like this. Okay, you can see it goes around the earth like this. Okay, now it keeps doing it once in 27.3 days, goes around the earth. Okay, so now if the moon is somewhere there, okay, what I am showing there, okay, if the moon is there, you can see that there is earth, moon and sun. Okay. Moon is in the middle of earth and sun. So if you are standing on the earth, okay, to see the sun, actually moon comes in the way. Okay, you can't see the sun. Moon is basically in the way. Okay. So solar eclipse happens. That means you can't see sun. That is solar eclipse happens. Okay, and whenever the moon comes on the other side of the earth, okay, then what happens? Why do lunar eclipse happen? You can see the moon, you can see the sun, isn't it? But think about this. We see moon only because sun's light falls on it. It's like an object which you keep in the room. Okay, you can see it only if light falls on it. Otherwise, you can't see the object. It doesn't have its own light. So moon, when it is here, the problem is sun is on the coming in the way of light coming from sun directly to moon. The earth is in the way. Okay. So what does it mean? That means earth's shadow falls on the moon. When earth's shadow falls on the moon, you can't see moon. Okay. That is when, or you can see a dim moon. Okay. That is what we call moon eclipse. eclipse or lunar eclipse. Okay. Now that we know when solar eclipse happen, when lunar eclipse happen. Okay. So now it's all straightened out. We know exactly how it happens, and this seems like a better explanation than Rahu and Ketu eating up sun and moon, isn't it? But wait, okay, I will ask one question. Okay, the question is this: how much time moon takes for one revolution to go around? You know the answer. So we did it in the last class, the first video. So it takes 27.3 days. Call it, let us say, 1 month, approximately 1 month. Okay. So you know why month is month? Because it is moon. Okay. Moon takes one round, and hence it is month. Okay. So 1 month is about one round of moon going around the earth. Now, if that is the case, so the question now, how many eclipses can happen in one revolution? So look at this. Moon goes from here to here, then goes down, comes up, goes here. So once in a month it has to go there, it has to come here. Okay. That means when it is actually here, when moon is here, it is basically called as Amamasya, and when it is here, it is called as Paurnime. Okay. Or in English, you call this as a new moon day, and this as full moon day. So now we know that most all the lunar eclipse happen on full moon day, which is consistent with our understanding, and all the solar eclipse happen on new moon day. That is also consistent with our understanding. But question basically is that in every month, since it goes like this, okay, every month we have to have one solar eclipse and lunar eclipse. On every full moon day, there must be a lunar eclipse. On every new moon day, there must be a solar eclipse. Does it happen? Think about it. Does it happen? So, how often do eclipses happen? Do they happen in every month? So, when I asked this question to many people, people were saying that actually it happens every month. Maybe some other part in the earth. Now, maybe in Arabian Seas, maybe in Pacific Ocean, maybe in some other place in Australia it may be happening, I don't know, but it is not happening in my place every month. So this is what I was told. Then, if you go through the details, you will realize that that is not true. Okay, it doesn't happen every month. So why is that the case? It may not happen here. It is not happening. For example, this new moon day, it may not happen anywhere. So how is it possible? They come in a line, but still eclipse does not happen. Can you think about it? Why it doesn't happen? Maybe all our theory that coming in a line will cause eclipse, is it wrong? Maybe that Rahu Ketu monsters eating the sun and the moon, that seems right. Think about it. Okay, let's now explore that. So, if you look at the moon's orbital plane, okay, what is an orbital plane? So you see here, there is sun here and there is earth here. Okay, earth going around the sun. Okay, and that going around makes one plane. Okay, that is called Earth's orbital plane. That is a plane. Okay, and around the earth, moon is going around. Okay, when moon is going around, that also makes one plane. Okay, and those two planes are not exactly coplanar, what we say. It is not the same plane. It makes an angle of about 5 degrees with respect to the Earth's orbital plane. This is Earth's orbital plane. This is Moon's orbital plane. There is an angle of 5 degrees between those two. Okay, and that is the reason why eclipses do not happen every new moon day and full moon day. You want to know why? You see that. Okay, so let me show you the a better picture to understand that. So look at this picture. Okay, here is in the middle there is sun. Okay, and Earth going around the sun. Okay, now you look at these two scenarios. Now where on this side and on the other side, and because of this tilt of the axis of lunar movement around Earth, you can see very clearly that though sun and Earth are here, moon is not in that line. Moon is slightly below that line. Okay, so that is what you can see in this side. On the other side, you can see, okay, because it is like this, the axis, and this is the plane. When it comes here, this is sun, this is Earth, and when you draw a line between them, actually moon is slightly above that. So though they come in a line, okay, in the sense they pass through, but it is slightly above that or below that in many places, only because they are not in the same plane. If they were in the same plane, it would have happened every new moon and full moon day. Because it is slightly tilted, okay, it happens, not always. Okay, now you look at this picture on the other side. Okay, there and here. Here there is, even though it is tilted, that point at which this plane intersects this plane. Now that is where actually if the moon comes, suddenly it comes exactly in the middle. Okay, and that point eclipses happen. Okay, so we can actually calculate, because it is not exactly that side, this side, and it keeps varying a little bit depending on the time. People actually can calculate exactly when sun, moon and Earth come in exactly straight line. Okay, not slightly displaced up or down. So that calculation, even our ancestors long back, they knew how to calculate eclipses. So they were actually not even very sure about the movement of the sun, Earth and moon, but sun is at the center. That was also not known, but still they knew exactly those movements. Okay, but they were actually seeing just from the sun, standing on the Earth, just watching them, sun and moon, how do they go in the sky, and their path they would trace. Okay, and then they will say, see this, they'll say basically, if you are in the middle, let's say you are in the Earth, because they are watching from the Earth only. Okay, they will say one path of sun goes like this, and the moon's circle goes slightly different angle. They realize that. Okay, and on those two circles, when they meet, at that point, if the moon comes and the sun comes, then only you will have eclipses. That they had realized. Okay, so those 2 points were considered to be something called as a descending node and an ascending node. Okay, this was somewhere around 7th or 8th century or 6th century AD in India. Okay, there was an astronomer and a mathematician called Brahmira. Okay, he actually named these nodes as Rahu and Ketu. Okay, he named the ascending node as Rahu and the descending node as Ketu. Okay, and the story of the monster eating up is actually kind of a metaphor to say that these 2 points in space are like places where when the moon and the sun enter, the eclipse happens. Okay, when moon and sun leaves that place, eclipses, it comes out of the eclipse. Okay, so it is not a real monster. It is more like a metaphor. Okay, so those are the 2 places, those points are actually called as Rahu and Ketu. And when it goes through those points, the actual they come in very perfect right line, and they don't come up or down. So this is all because of the plane of motion of the moon around the Earth is not in the same plane as the plane of motion of the Earth around the sun. And these 2 points are called Rahu and Ketu. So now, do you agree with the Rahu and Ketu theory? So look at this. Our scientific explanation is correct with a better understanding of it, of course. And the Rahu and Ketu theory are also correct, except that Rahu and Ketu are metaphors of monsters, are not real monsters. That is all. Okay. So let's now go forward and just dwell a little bit into the how this eclipses happen. Okay, and what are the kinds of eclipses. I'll spend a little bit of time before wrapping it up. So first of all, I want you to understand how the shadows actually form. Okay, if you see the shadow, Okay, you can see the shadow here. There is always a center shadow which is very dark. Okay, and there is a slightly side shadow which is a lighter shadow. Okay, so we call that center shadow, the dark shadow, as umbra. Okay, and the external shadow, that slight peripheral shadow, side shadow, we call it as penumbra. Okay. So why do they happen? It is only because the light source is not a single point object, it is extended, and hence some part of the light, in the middle part, none of the light from this source will reach, whereas in the side part, some part of the light from the source will reach. That is why it is slightly dim kind of thing. Okay, so a lighter shadow. So now we know that there is always, whenever the shadow happens, there is a central shadow which is called a core shadow or a umbra, and a penumbra, the surrounding shadow. With this in understanding, we will now transform that into sun, moon, earth scenario. Okay, now you look at this. Here there is your sun, and moon is in the middle, and earth is there. And you can see that the moon's shadow falls on the earth. And there again you can see there is a central core shadow, and there is a umbra and penumbra. Okay, that core shadow, whenever you are there in the core shadow, let us say you are standing in the core shadow, okay, then you can't see sun at all. So when you can't see sun at all completely, okay, that part when you are standing, you get basically completely total solar eclipse. You can't see any sun. Okay, whereas if you stand in this penumbra, where there is a slight amount of darkening and not a complete dark shadow, in that area if you stand, then you can see sun partially, okay, not fully. So this is basically partial solar eclipse. That is how total solar eclipse and partial solar eclipse can happen. Okay, if you are there anywhere else, then you can see the full sun and there is no eclipse. Okay, so now if you see the types of eclipses, this is called as a beautiful, completely dark solar eclipse, which is basically total. How does that happen? We just now talked about. It happens by looking at sun's shadow falls on one point in the area there on the earth, and if you are standing at that point, you see a total solar eclipse. On the other hand, okay, there is one more very beautiful total solar eclipse that is called as a annular or a ring eclipse. You can see a nice ring like this. Okay, and this ring eclipse happens because if the moon actually goes around the earth in an elliptical path. Now sometimes it is slightly nearer and sometimes slightly farther. Because of that, what happens when it is slightly further, it does not cover the full sun. Okay, when it is slightly farther, you can see the second picture, moon is slightly more farther from the earth. Okay, so there what happens, the moon's shadow falls like this, and there is a little bit of area there around which you can actually stand there and see some surrounding portion of the it is also total solar eclipse. I mean, full sun is covered by the full moon very nicely in the middle, but it is just the distance is such that there is a certain area of the sun which gets not covered. Okay, and you can see that. That is an annular solar eclipse or a ring solar eclipse. Okay, and the third one you know very well, I said, is a partial solar eclipse. That means it's not complete, it's only a part. The part of the sun you can keep seeing. Okay, that happens mainly because of what? Because your shadow. Okay, you are in the you can see that you're standing on the penumbra. Okay, you're not in the middle of the core of the shadow. Okay, not in the umbra region. So that is why you can see part of the sun. So these are the three kinds of solar eclipses that are possible. Okay, now when you go into lunar eclipses, what are the things that are possible? So lunar eclipse also are multiple types. Okay, we call it as partial, and then we call it as total, and thirdly we call it as penumbral. Here we use the word penumbra directly. Okay, in penumbral actually what happens is it looks like it is covered, but it is lighter. So I showed you, light shadow, because earth shadow falls on the moon. little bit of light also falls, and hence it looks like slightly, it's not completely dark. Okay. So, if you look at total, okay, you can very clearly see that the central shadow directly falls on the moon. Okay, moon is inside the central shadow, you can see, and it's a total eclipse. And second one we said basically partial, where you can see it is not inside the complete cone of the umbra, but slightly outside, half inside, half outside. Okay, that kind of a scenario is called as a partial lunar eclipse. And finally, the penumbral is you are completely inside. You are not at all in the central cone. You are there in that area which is slightly shaded. You see, it is a penumbral region. There you can see that the moon just gets a little dimmed down. Okay, that is called penumbral solar eclipse. Sorry, lunar eclipse. So now we have understood the types of lunar eclipses also. Okay, so this I hope had given you a good understanding of how eclipses happen, and the types of eclipses, and the mystery of Rahu and Ketu. Okay, so enjoy, and we'll come back with another version, another episode of the solar system. Thank you.